In this video, I'm going to talk about your Math 139 Piecewise project number 1, that piecewise function with linear pieces. Right. So in this assignment, the first thing that you're going to do is choose a data set to work with. See options below. So in the second page, there are several different data sets that you are able to select from. We'll talk about each of those a little bit later, but you will click on your data set and look for one that has at least 3 linear pieces. Select data that can be modeled with a piecewise linear function that uses at least 3 pieces, and each of those pieces should have at least 4 data points. Okay. Now, I'm going to be using a different data set during this example, and I will show you how to walk through the project. So the data set I've chosen is not one of the options for your project. It is a data set here on child mortality rate of Somalia. And again, I just chose this particular data set because it does appear to be piecewise linear. When I look at this data set, I see piecewise linear segments from here to here. So this first data point, which is the 1982 data point, all the way until this data point, which is representing 1992. It looks piecewise linear for those span of years. I see a different slope, pretty much constant slope, between 1992 and 2006. So again, that's my second piecewise linear segment. A different line would go through the data points right there, and then the pattern changes again, and I see a different line over here. So I would like to make 3 different linear sections for this data set. All right. So according to the directions for the project, I identified 3 pieces. You can do 3 pieces or 4 pieces depending on the data set you choose. 3 pieces are going to work for this particular example. So I'm going to grab a Desmos window, and I'm going to begin by making folders. You can either type the word folder, or you can click on the plus sign and add a folder. And then I'm going to name my folders piece 1, another folder here, piece 2, another folder here, folder, and piece 3. So I'm going to have 3 pieces. All right. Back up into my first folder, I'm going to make a table. You can either type the word table or click on the add item icon and add a table. All right. Now, I do need to declare my starting year. So I'm actually going to do that up here above the folder. I'm going to be working with years since. Well, my first year in my table is 1982. I could count from 1982, but I could choose 1980 to count from because it makes the counting more convenient. It's a nice round number, ends in 0. That's near my starting year. So I would like to choose 1980. If you don't write this in your Desmos tab, that's fine. You'll want to make sure in your project that you write that part in the by hand piece for sure when you state the meaning and units of both of your variables. So you would need to tell me what your year is counting from if years are your independent variable. So I'll get to that portion in a minute, but I need to do that before I can begin my table. So I have 2, 4, 6, 8, 10, and 12. Okay. And that was because for this segment, 1982 was going to be the first value in it, and then I would go for 1984, which is the second year, 6, 8, 10, 12. I wanted to stop this one in 1992 because that point seemed to be the last point of that decreasing trend for my first segment. That's why I've chosen to go from 2 to 12 for this particular data set. Now I need to take some time to enter the dependent variables from my data table over here. I'm just copying those down into Desmos for each of the years, writing down the child mortality rate. All right, I'm going to zoom in over on my data, that is zoom fit button, and I'm going to make this window larger. Okay, so this is the data for that first segment. Now I'm ready to write the model. So I'm going to use regression to write the model for this segment. So I'll use y1 approximately mx1 plus b. This is table 1, so my variables are named x1 and y1. And I want to rewrite this function. I'm going to call it f of x equals I can use my value for slope. I will round that probably to 3 places. So if I round that to 3 places, the 8's going to turn into a 9. And I will have x plus b also rounded to 3 places. I'm going to change my variables in a moment here. Oftentimes, we use t for time for years. So use whatever you wrote on your paper. If on your paper you said t is years since, then use t. So I'm going to assume that I used t here. Now, the name that you use right here does not have to match what was on your paper. What matches on your paper is what you write for your by hand function. I'll talk about that in a little bit. But for right now, I can use f, or I'm actually going to probably call it f1. F is just a generic name. Perhaps I would call it M for the mortality rate, or S for Somalia. But generic name F right now. And I'm going to use F1 because I'm going to have 3 different functions, one for each of my 3 pieces. This is just the first of those functions. You don't have to use F1, F2, F3, which is what I'm going to do. You could do F, G, and H if you wanted to instead. Okay, now that I have my function, I will turn off the regression. And we're going to note to ourselves that we don't want this line continuing forever. Specifically, we don't want this line to continue past 12. That's when the piece should end. So we're going to include a domain restriction here to say where this piece should be graphed from. I can graph this for t values less than or equal to 12. I knew that 12 was the ending point because that was the transition point on my graph over here. Remember, at 12, we changed from that decreasing pattern and began the constant pattern. So 12 was the input that was that transition point. So that's why I said I wanted my t values to be less than 12. If you also do not want your data to go before the x-axis or before your first point, you could make it a 3-part inequality. So for example, perhaps I don't want this one to go past 0. I could go from 0 to 12. Okay. So I'm going to leave mine like this for this example. That's my piece 1. I'm going to minimize that and begin work on piece 2. I'm going to make a second table. I need to enter my data points. Let me make this a little smaller. And now I'm going from 1992 all the way through 2006. It's very important that I continue counting from the same starting year. So 1992 is still 12. Then I have 14, 16, that's 1996, 18, 20 is 2000, and I'm going to go all the way until 2006 because I can observe that that's the last value that seems to be pretty constant. So right in our output values, we have 174, 173, looks like a bunch of those. So 173 again in 96, 173 again in 98, 173 again in 2000, again, and then 172. We observed that this appeared pretty constant, and we're seeing that that's true over here in the data points because they're almost all the same value, so it is pretty constant. Tiny bit of discrepancy over here, that's okay. So mostly overall flat. Now I can't see those data points. I can click the zoom fit, but if I do so, it will no longer show me my first line. So instead I'm going to choose just to extend my x-axis, and I'm going up to 26 right here, so I'm just going to extend past that. Let's say I go to 30 or something like that. Okay, so now I can see all of those points. Okay, so we will continue. We'll do our next regression for piece 2. This table uses x2 and y2, so y2 approximately mx2 plus b, and we'll write the function. I named the first function f1, so I'm going to name the second function f2 of t equals. All right, so my slope, I'm going to copy and paste that value, and I'm going to round it to 3 places, plus I'm going to round my b value to 3 places as well. Turn off my regression now that I've written my function, and then we need to restrict our function. Second function, I would only like to see this function between the input of 12 and the input of 26. So we're going to go from 12 less than t less than 26. Okay. Now, I didn't put the equal bars on these yet. Traditionally, I did put an equal bar on 12. That's a choice. So I can choose which of these to put an equal bar on. Do I want it on the first function or the second function? It's a choice. So it doesn't really matter because they're very close together. Both functions are going to do just about as good of a job as the other, predicting at 12. If you think that one function does a better job at predicting the value at 12 than the other, this one's a little higher, this one's a little lower. So I think either one would be fine making that prediction. So make a choice. I do not want to have the equal bar on both parts. So let's say, for example, I'm going to put on the 12 in the first function, so I will not put an equal bar on the 12 on the second function. I'm going to go ahead and put an equal bar on the 26, and then we will not put an equal bar on the 26 in the third piece. Okay, I'm going to go back and color code some stuff. Since the dots happen to be green for the first segment, I'm going to make my function here green for the segment. Since my dots happen to be purple, let me just go ahead and make my line purple so that it just looks a little more appealing. I can see that my dots and my function lines are, my function colors are now the same. All right, so piece 2 is done. On to piece 3. Okay, so piece 3, let me make this a little smaller again. Piece 3 is beginning in 2006. That is where the decrease happens. It starts first from 2006 to 2008, and then it continues all the way through the end of the data at 2020. We're going to make sure, again, that when I start the table, I'm counting from the same starting year. So 2026 is, sorry, I misspoke. 2006 is, there we go, 26 years after the starting year, which was still 1980. The same starting year is being used throughout, so I am using 26 for 2006. So I will have t-values from 26, 28, 30 would be 2010, 32 before, 36, 38, and 40, which is going to correspond with 2020 being 40 years after 1980. Go back and enter my values for output. The border values, like 26,172 and 1992's border value, appear in multiple charts because my graph is connected. If yours is not connected at one of those places, you may not be using a border value twice. But it is appropriate in this case because the segments do look fairly close. The ending point of one is also the beginning point of the next. All right, so I need to look at my numbers. For 2010, I have 158. Okay, I'm just going to enter these numbers. All right, and make this bigger. Now, again, I can't see the data points. These are purple. I've already used purple, so I'm going to change to red. And I can see the end of my table is now at 40, so I better expand this to make this go to 50. Okay. Now, I also can tell that my Y values have decreased below what I can see. So I'm going to drop that Y minimum down to, say, 100 or perhaps 90, just to make it obvious that my graph is showing all the values now. I had to drop below what was visible from the previous two graphs. Okay. Back up here, another regression. This is table 3, so we'll do Y3 approximately mx3 plus b. And you can call your functions like f, g, and h if you want, h of x, or I was using subscript, so this is my third f function. So f of t is equal to, we're going to round these guys to 3 places again. So that's going to round to 0.238t. There we go. And then rounding to 3 places. Our b values have already had 3 places. Turn off the regression and enter your domain restriction. So remember, domain restriction here is that I would like this function to begin at 2026 and then continue past there. So I would like my t values to be larger than 26, representing 2006, right? The 26 input meant the year 2006. Okay, so I'm going to just say it's going to go from there and it's going to continue onward. I do not need to stop it at the end of my data because I may want to use this to make a future prediction. What if I wanted to make a prediction for what's going to happen 50 years after 1980? So what's going to happen in 2030? I can use this to make a prediction if I allow my most recent line to continue. Okay, so that handles the mechanics of the piecewise function. Let's take a look at some of the other aspects of the project. All right, so project one, our mechanic pieces are we're making the folders, piece one, piece two, piece three, etc. Each folder has a table with at least 4 points. We've written the equation. You can use regression or you can write them by hand. That's up to you. I did regression for all of them in my example. That was my preference. And I used inequalities to restrict the domains, as you could see. Okay, that's the part that you're going to do on decimals. I'm going to take a look at some of these data points now. So in the first one, some of these data sets. The first one's on new family homes. So if I look at this data set, there are several roughly linear shapes. So I can see from about 1990 to about 2005. That is one broad, roughly linear shape. There's another one from about 2005 down to 2010. Another one from 2010 to 2020. Maybe another one from 2020 down to 2022. So I could see some broad shapes where I could do swish, 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 make some linear graphs here. Okay, so if that's the data set you choose, you're going to use the hover text to write down ordered pairs for your data. Make sure that you're very careful in what you declare as your starting year. This data is by month as well as by year. So you may want to grab just the Januaries, for example. So I might start in January 1991 and then find the data point for January of 1992. There it is, and record that one. I do not recommend that you record every month, but perhaps the same month every year would be enough data to make yourself a nice model. Okay, that's one of the data sets you could choose. The next one is on extreme worldwide poverty. This data set is a little different. There are actually two graphs here, one in green and one in red. If you're doing the green graph, you might be able to observe that it looks roughly linear from my cursor down to the initial point, and then again roughly linear from my cursor up to this transition point, and roughly linear from that transition point up to the top. Or in the red one, roughly linear from the beginning to perhaps this value, and then again from that value to that little dip right there up to here, and then down to the other side. So you could get 3 functions for either one of those. You don't need to do both the red and the green, but you can decide if it looks piecewise linear in the number of people who are not in extreme poverty, or if it looks piecewise linear in the number of people who are in extreme poverty. I would like to remind you that you need at least 4 data points per segment. So if you're doing the green curve, you watch the dot here. There's 1, 2, 3, 4, 5 in that first segment. If I look at the second segment, I have 1, 2, 3. There's only 3. That's okay. It just means that you would want to estimate a third point. So you might estimate something right here. So if this point is data point for 1929, and this is the data point for 1950, you could estimate that in 1940, say, it was, and you would trace over and try to get an estimate for 2.25 billion or whatever the value you observe happens to be. So there is some need to estimate data points in a few of these where 4 data points are not necessarily shown. So that's something to consider if you're trying to decide which of these data sets you would like to use. And if you're looking at this data set, if you want to choose the red or the green. All right. The next one we could look at is the rhino population. That hyperlink actually opens up in the map. I do want to move that over to the chart. That's what you would like to look at as you're looking at this population. And hopefully you can see where you might be able to find 3 separate lines that model this data well. Knowing again that you need 4 data points, so there might be some need for estimation. For example, if I consider the first segment to go from 1960 to 1980, there are only 3 data points given by these dots, but I could estimate what it was in 1975, for example, to get my 4th point. Okay, number of breweries. This is again just another data set. You could look at this and find 1, 2, 3 or so pieces, and this one does not have hover text, so you would need to be estimating if you chose this one. All right. So further on in the project, you're going to define your variables and state their meaning. Make sure if time is one of your variables that you clearly state what year you're counting from for every part of your model. Also state what your dependent variable is with its units. That will help me know which data set you chose to work with. Then we get to the part of writing the piecewise function by hand in standard notation. Okay, so when we work in Desmos tab over here, when I wrote this function on Desmos, I did not write it in standard notation. I wrote it in 3 separate functions that I could use those functions in Desmos. If I'm going to write that function in standard notation, it will look like this. So depending on what you're going to name your function, mine is about mortality rate, so I'm going to call it M, and I would write that down in my project. I'm going to call it M of T. And then I'm going to have a large curly brace, and I have 3 pieces to this function. So I'm going to have 3 different pieces of my function. Again, I'm typing it instead of handwriting it, but when I finish this, you'll get a chance to see what it should look like handwritten. So piece 1 is the function negative 2.629t plus 206.067, and I use that piece for t values between 0 and 12. Then I will look at my next function, and that'll be the next piece. Okay, so my next function, that was negative 0.083 t plus 174.583, and I was going to use that piece for t values between 12 and 26, making sure that I watch the equal bars, that I get to include the 12 in one of those, but not both. All right, so we have the idea. I might as well just finish up how this looks by hand with my third piece here. We'll select the function negative 4.238t plus 283.857 if the t value is greater than 26. Okay, so that's what we are intending that you would write something to that effect using the variables that you declare. So it's one function grouped together with that curly brace on one side, where you write down the 3 equations and the criteria for when you will use each of those 3 criteria. That's what a piecewise function should look like in standard notation by hand. Okay. After that, we analyze the function. So number 3, we discuss and compare and contrast the slopes of each piece. In my example, the slopes are all negative, so I can notice that all of them are decreasing. That's good in this situation. Since I'm talking about mortality rate, it's good to know that it's decreasing over time. And I can further say that between the years 1980 and 1992, the child mortality rate was decreasing at a rate of negative 2.629 deaths per 1,000. Those are the units from my data set. Then it was almost constant for the period between 1992 and 2006. Unfortunately for this data set, the child mortality rate started dropping more rapidly at a rate of 4.283 deaths per 1,000 after this 26, which stood for, this stood for 2006, after 2006, and it has continued through 2020, and we can hopefully expect this to continue into the future. So those are some statements. They should make sense to someone who has not necessarily looked at the data set. Talk about your values. Compare them. Mine were all negative, so I'd say they were all decreasing. I talked about the size of the values, how this one had the largest negative slope, and what that meant for this situation. That's what we're looking for here. Just a discussion, some comparing and contrasting those slopes. You may have some that are positive and some that are negative. Tell me about it. What does it mean for the situation if the positive slope versus a negative slope? What does it mean for the situation for a large value versus a small value? Okay. So the last piece is to make 5 observations about the model. You have a lot of flexibility in what you can choose. You can just select specific function values. You can look at maximum points or minimum points. You can emphasize aspects where your function is increasing or decreasing or constant. Domain and range are considerations. You can talk about where model breakdown has occurred. So for example, in mine, let me locate it real quick here. In mine, I could talk about how the vertical intercept would suggest that in 1980, the child mortality rate was 206 per thousand in Somalia. I could look at the t-intercept and suggest that 66 years later, which would be in 2046, the child mortality rate in Somalia will reach 0. I can make a prediction for this year. I could say, I don't know what my prediction is, but let's see, this year is 2023. So if I subtract my starting year, that would be an input of 43. I can plug that into my most recent function segment and say, hey, in this year, I would predict the child mortality rate in Somalia is going to be 101.6 per thousand. I could talk about that area of constant, and if I can think of any reason why that might be constant, why the mortality rate was not decreasing, I could talk about what that segment means in terms of the graph. All right, so that's just a few examples of things that you can identify in your graph to talk about. Find 5 things and talk about them, but please do make sure they're not all the same. So if I make a prediction for this year, don't also make a prediction for next year. We don't want 2 predictions, 2 of the same type of thing. Just give me different things. There's plenty of things that you can choose to talk about.